Hello everyone, welcome to my channel. Today I will take you through my latest project, the University Course Management System. This project models various courses offered at University of Karachi by using core object oriented programming. It is a great example of how programming concepts like inheritance, encapsulation, and polymorphism are used in real world application. So let's get started. This is the overview of our project. In this project, we are going to create a university course management system that manages courses such as programming, mathematics, science, and language. Each course has its own specific requirements, and a student can enroll in any course they want. Next, there are four main core principles in OOPS: inheritance, abstraction, polymorphism, and encapsulation. First, we learned about what these principles are, and also we know we use this principle in our project. Number one, we have an inheritance. Inheritance is indeed a fundamental concept in object oriented programming that allow you to create a hierarchical relationship between classes. It is like a family tree where a child class inherits the attributes and method of its parent class. We have a in this project we have a course class that act as a base template. Each specialized course like programming course, mathematical course, science course, and language course inherits attributes and method from this base class. Next, we have an encapsulation. Encapsulation is a concept in programming that means hiding the internal detail of an object, only allowing control access through methods like getters and setters. It helps protect the data from being accidentally changed and ensure that only the class itself manages how its data is used. Think of it like a capsule. Important details are kept safe inside, and only specific tools, methods can access or modify them. Here, in this project, we use a private attributes to restrict direct access to variables like the course name, instructor, and credits. Instead, we create a getters method to retrieve this information safely. Number third is polymorphism. Polymorphism in OOP means the same function or method behaves differently depending on the object calling it. It allows method to be overridden or used differently in child classes. In this project, different courses have unique schedules, so the get schedule method is overridden in each subclass to display course specific schedules dynamically. For example, programming course show lab session while science course display experiments. At the last, we have an abstraction. Abstraction in OOP means hiding complex implication details and showing only the essential features to the user. It simplifies interaction by focusing on what an object does rather than how it does it. For example, think of driving a car. When we press the brake pedal, car slow down. We don't need to know how the braking system works internally, hydraulics, pads, etc. We are only interested in driving a car. In this project, complex operations like student enrollments are abstracted within the enroll student function. User only need to provide a student name while the intricate details of updating course roster are handled internally. Now, hopefully you all have the idea of what OOPS core principles are. It's time to use this concept for making university course management system. So let's walk through the code. Let's start with the base class, which I have named course. This class is the foundation of our system because it stores common details that every course will need, like the course name, credits, course code, instructor, and semester. We have used encapsulation here by making the attribute private. That means these variables such as course name, credit, course code can't be accessed directly from outside the class. But we have also provided a getters like get course name, get credits, get course code so that the data can still be accessed when needed. Here we define some method just like gets labels. It hides the internal structure and provide a public way to access course labels. It is an example of abstraction. Here is another get schedule method. It defined a general course schedule. This method is overridden by the child classes to demonstrate polymorphism. Next, we have an exacting part, inheritance. We have four specialized classes: programming course, mathematics course, science course, and language course. Each of these classes inherited from the course class, which is our parent class. This means they get all the attributes and method from the base class, but we can also extend and override them. Just look at the programming course. It inherits everything from the course class, but also add a new attribute, programming language. We also overridden the get schedule method to include lab session which demonstrate polymorphism. In the same way, the mathematics course class add a math field, attributes and provide a get formula sheet method. For science course class, we have added a new attribute science field. Also override the schedule method to match the specific need of math and science courses. In the same way, we have made a language course. It also use a new attribute language and also use a new method get language guide and also use a get schedule method just like as other classes used. Now let's talk about the student enrollment. This function enroll student take a course and a list of student as input. It asks the user to enter a new student name and add it to the list and display the updated list. This function is a great example of encapsulation. Since we are managing the student list inside a function, the details are hidden from other parts of the code. Now let's talk about the course info function. This function displays the course details along with the student name, enrolled student. Notice how we use a polymorphism here depending on the type of a course. We call a specific method. For example, if it is a programming course, it will display a practical exercise. If it is a mathematical course, it will display a formula sheet, and for a science course, it will display a lab manual. Next, we have created four different courses object, one for programming course, one for mathematical course, another for science course, and last for a language course. Each object is created using the respective child class and we have passed appropriate values like the programming language or the math field. Now comes to the final part, displaying course info and enroll student. Here we first call the course info to display the course details. Then we call a enroll student to let the user add a new student to the list. We repeat this process for all the courses to make sure we capture courses specific behavior using polymorphism. Alright, now let's see the output of this program in action. I have already run the code and here is what the program looks like in the terminal. Programming. Here you can see all the information, course details, the name, instructor and the student enrolled. Because this is a programming course, it also displays information about the coding, assignment and exercise thanks to polymorphism. Next, the program asks me to enroll a new student name. Let's try entering a new student name. I will tap Ali and press enter. As you can see, the program prints the updated student list with Ali added to the course. Next, the program repeats the same process for the other courses. Let's look at the output for the discrete mathematics course. The program displays all the course details just like before. For math course, the schedule mentions 4 theory lectures and a problem solving session. We also see the formula sheet information mentioning that it covers set theory which is specific to this course. We enrolled Ahmed in the discrete course and the student list was updated just like before. The same structure applies to the physics and English courses. The science course includes a lab manual and the language course has a grammar guide. As we see in the output, each course scheduled in different based on the. For example, programming fundamentals include coding assignment and a lab session. Mathematics has theory lecture and problem solving session. Physics has lecture and lab experiments. This is a perfect example of a polymorphism. The same get schedule method behaves differently for different course types. And that is how our course management system works in action. It smoothly manages courses details, schedules, and student enrollments while showcasing key principles like encapsulation, inheritance, and polymorphism in them. Let's quickly recap the OOP concept used in this code. Encapsulation, where we have hidden courses details behind private attributes and provide getters to access them. Abstraction functions like getLabels hide complex logic and only shows the inheritance. Child classes like programming courses inherit properties from the base class course. Polymorphism. Method like getSchedule behave differently based on the course type. And that is a run. I hope this walkthrough helped you understand how a concepts like inheritance, polymorphism, and encapsulation come together. Thanks for watching, and I will see you in the next one.